Hello, we are going to learn how to evaluate all 6 inverse functions. Yesterday you looked at evaluating sine, cosine, and tangent inverse. We're going to add on cosecant inverse, secant inverse, and cotangent inverse. So remember that secant is equal to 1 over cosine, cosecant is equal to 1 over sine, cotangent is equal to 1 over tangent. But when you think about the inverses, the secant inverse of a value is equal to the cosine inverse of its reciprocal. The cosecant inverse of a value is equal to the sine inverse of the reciprocal. And the cotangent inverse of a value is equal to the tangent inverse of that value, 1 over that value, sorry. And we're going to use this to simplify our situations on the next page. Now, if you are one of those people that wants to know what those inverse graphs look like, I went ahead and graphed them. This is the secant inverse graph, not the dotted part, but just these 2 little pieces. And they come from the principal interval for secant inverse. And if you'll notice, the range is 0 to pi halves with an asymptote at pi halves, and then pi halves to pi. So just like cosine goes from 0 to pi, so does secant inverse, except it has an asymptote at pi halves, just like secant has an asymptote at pi halves. Cosecant inverse goes from negative pi halves to pi halves, which would be the 4th and 1st quadrant, just like sine inverse, except this one has an asymptote at 0. So cosecant is going to have an asymptote at 0. And then cotangent does not relate to tangent in this sense because it's going to go from 0 to pi, 1st and 2nd quadrant, but it's going to have soft brackets on the 0 and soft brackets on the pi, where if you'll remember, tangent inverse goes from negative pi halves to pi halves. So these are called the principal intervals, and they go along with the range. And then, of course, you can see the domains here. We're not going to test you on those other than knowing the intervals, knowing the quadrants. So that's what you need to know. If you're a picture person, I've got this in pictures. So this helps you remember where to look. So you've got your cosine inverse, secant inverse, cotangent inverse are going to be in the 1st and 2nd quadrant. And then your sine inverse, cosecant inverse, and tangent inverse are going to be in the 1st and 4th quadrant. So that should help you in solving these problems. So if we use the ideas I talked about, if we have secant inverse 2, according to that page I put up, that would be the cosine inverse of 1/2. And then you're going to go and you're going to look at your unit circle, and you're going to look at where 1/2 is in the 1st or 2nd quadrant for cosine, and you're going to see it at pi over 3. Okay? And then when you have arc, remember arc's inverse is just another way of writing it. So arc cosecant can be changed to sine inverse or arc sine of 1 over root 2. So again, that's positive. Look in the 1st quadrant. When you look at the 1st quadrant, you should see that as being pi over 4. Now on this next value, we have arc secant again. So we're going to change that. And you could write arc instead of inverse. So arc cosine. And you're going to flip the value, because when you take the reciprocal, that's just flipping the value. Now, when it's a negative, I have to think about quadrants. And so I'm going to look in quadrant 2, because inverse cosine is only in the 1st and 2nd quadrant. So in quadrant 2, when is cosine negative root 3 over 2? And that happens at 5 pi over 6. Then we have cotangent negative root 3. We can change that to, actually, you really shouldn't change that. You really should realize that if it's negative, I would only change the secant and the cosine, secant and cosecants. I'm going to leave the cotangent as cotangent. So you want to look to where in the second quadrant, okay, where x over y is negative root 3, okay? And so if you look at where x over y is negative root 3, you're going to see that at 5 pi over 6. So cotangent, I would just stick to cotangent. I wouldn't change it to tangent. Cosecant inverse, I'm going to change that to sine inverse of 2. Now, guys, on your unit circle, has sine ever been a value of 2? No. The biggest sine ever is 1. And so this is going to be undefined. Okay, this does not happen. So not only is sine inverse never going to have a value of 2, cosecant inverse never has a value of 1/2. So, and you can write no solution also. Then this one is going to be cosine inverse of -1. Again, this is in the second quadrant. Okay, so where is cosine -1? And that's going to happen at pi. Okay, because when you flip -1, it's still -1. Okay, so really just remembering to flip the value if it's a cosecant or secant and change it to sine or cosine. And then cotangent and tangent, you can just leave alone. Good luck, and that's the lesson today. Thank you.